Hi everybody. I never liked doing this, to be totally frank. I may just stop. But anyways, so we're gonna be making a server in Go. The reason we're making a server in Go is one, we want to be able to serve static content to the user. In the case for me, I was running a user study where I wanted the players to play a game on their browser. I then wanted them to be able to send their logs back to the server and then for those logs to be stored. So that's our second use case. So static files and then receiving logs. And then the third reason why this is an actual interesting video, and it's in the title, which is we're going to be doing block randomization of conditions. So basically, the way I would think about this is a condition, if you know like alpha beta testing, right? You just have like two difference, but there's nothing saying there can't be more than two conditions, right? And there's conditions A and condition B in this case. And if we have like 100 participants in our user study, right, we want 50% to get condition A, 50% to get condition B. At least that's generally what you would want. I'm having trouble coming up with an example where you would want like a 75-25 split. So we're not really going to get into that. But 50-50 is what you want. And generally what you can do here is you can do something called random condition assignment, right? So you just make like, just to use like, we're not even using Go yet, but like 0.5, right? You would return A, else return B, right? And this could be our def random condition. So this is very Python pseudocode-y, right? I think it is actually just Python if we just add like from random import random. But this is like random condition assignment. Now, there's a problem that I ran into when I ran a player study, which is that when you use random, you're likely to get like a 50-50-ish distribution, but the smaller the number of conditions you have, the less guarantees you have about that like random distribution of where you're going to end up. Are you going to get at the top of the bell curve at 50, or are you going to end up over here for condition A or condition B, right? And so I had one where I wanted 50 per, I had 4 conditions, and I wanted like 50 participants per condition. So I had 200 participants in my study. Participants, not participants. Participants, right? And I had one get like 70, like condition A got 70, let's just say, and condition C got like 30. So I had this like terrible distribution, and since I already ran the study and the money was already spent, there was nothing I could do. But it was a lesson learned, and it's something I can fix going in the future. And the way you fix it is something called block randomization. Now, exactly how block randomization works, we're going to get into, right? But before we actually get into that, we need to just start coding our server. So let's start doing that. So we're in this little project right here. We're going to do go mod init, go log study server, right? ls, I lost my, oh, I need to actually open this. And then, of course, this isn't in the right spot. 1 second. So now this should be on the right screen. It is. Cool. So I think we are now good to go. Looks good. Sorry about that. Okay, cool. So we're here. We can do mkdir src. I just like doing that, to be totally frank. And let's go into src. We're gonna make two files just because I know we're gonna need it. The first is gonna be touch server.go. The other is going to be block.go. And I do want to be fully transparent here. I am no Go expert by any means. If anything, I'm a Go newbie. But it was a very convenient language to use for this problem. So I just want to kind of show off what it's like to use. And I am sure there are other people who have used Go before who will see what I'm doing and say, Colin, you have no idea what you're doing. Here's how you can improve it. And that'd be great. So we always need to package main it. And then the first thing I want to do before we even like do anything like crazy, func main, and then if it's like fmt print ln, nope, there we go, hello world. Is this like too, yeah, this is, I'm really in the C+ world here. C++ world. I totally messed that up, but I actually want to use, I think this is fmt.print. Oh, yeah, there it is. There it is. So just kind of showing off, I am no Go expert, but I can make a server in it. So there it is. Go run src, and we're just going to do server.go for now. We get hello world, so we are off to the races. So basically what I'm going to do is I'm going to set up this I'm going to first set up some globals, and I'm just going to copy and paste them over here. And in terms of like best practices, there's no reason to say you have to do like this kind of like long comment, little comment kind of thing. It's just something I like, and I'm going to keep our block separate for right now. And you can also see the conditions we have. This is from my study, but for us, let's say A and B. So there's our log path, log directory. And so the first thing we have to do when we're actually running, and let me actually just include, I'm not actually going to import it. It's just because I know I'm going to need all these at some point. So I'm just going to put these here. And when they become relevant, we'll start adding them. Okay? So I'm going to yank that, put that there. And then what we can do is the first thing we want to do is we actually want to start making a directory if it doesn't exist. And so there's a couple of directories that we actually need. The first is going to be where we get our static content from. So if there's nothing there, we're going to make it. So this is going to be dir static. And I'm just following the actual like naming conventions. I personally don't like it. I'd rather do like dir static like this, but we're just going to follow the naming conventions right now. State or stat, and we're just going to do static. We need to do this, add import to OS. So now we're getting errors because these things are not used and you need to use them. Is not exist, that's right. And then we can do error static, right? And then we can do this, and then we can use their log fatal instead of like the log we made in the Sokoban series, right? And oh yeah, sorry. So then we can do like static directory must exist. So we're not actually making it. We're saying if it doesn't exist, then this server really isn't gonna work very well. Otherwise, we also need to check that dir static is a directory, because if it isn't, then it's not going to work. So we can also do a log fatal again. Found file named static, but it must, not should, a directory. So we can do something like that. Perfect. So this is going to be make sure the static directory exists before starting the server, something like that. And because that's not long enough, we're just going to take this to 80 for this. So we'll do this, and then we have another one coming up, which is what we should have done at the start. So right there it is. So dir os.mk dir all. So we're just making a directory. We're going to pass it in this log dir, which is right here. So file path.join, the current thing, and then this is going to be a directory called logs. Right? Pretty simple. I hope OSD mode perm. And so this just tells you the kind of file mode that it's going to be. So that's easy enough. If error, what did I mess up? There it is, error dir, right? So we have this, and what we really is does not equal nil. Then what we can say is we have an error, and what we can say is just pass it in error dir, and it will give us some kind of error message to tell us this. And we're going to add a nice little comment, make sure log dir exists. If I'm being totally clear, I would say all this stuff we can just do it like this because we're really just doing directory checks, right? We don't need to separate each one out there, but we do want to start doing it from here on, because now what we do is we're going to do start server. Okay, so there's going to be two functions that we want to be able to handle. The first is we're going to have like a func data logger, something like this, and then the second one is going to be func get condition, and we'll have something like this. So we'll just keep that, but what I want to do is I want to do go run server or src star. So we found an EOF, and that's because, so we'll just put this out for right now, and we'll put it back in when we want to. So you can see we ran into an error, which is that static directory must exist. And you can see there's like kind of like, we really want something like this with a space for a better life. So now if we run it, we have an error. Cool. So we're going to make a static directory, and we're going to put in an index.html, h1, hello world, right? Looks good to me. So now if we do it, hello world, we are rocking and we are rolling. Okay, so we have our functions. What we're going to first start doing is we're going to actually, just for a little bit of a cleaner like setup, first we're going to set up our file server, and then we'll come back. Let me just type it out. HTTP handle func. So we're going to pass it in a path, like an HTTP path. So this is going to be log, right? And then we're going to pass it in a function, data logger. But we're not going to actually call said function. The next thing is we're going to pass it in a condition, and we're going to pass it in our condition. Get condition, delete that. And so now we're serving for when the user wants to send their log files to us and when they want to get a condition from us. Now we have actually implemented that, if you recall, they're right there, but we're going to get that in just a second. First, we're going to actually set up our server, which should be hopefully pretty easy. So it's actually amazingly easy, to be totally frank. When I did it, I was shocked. Okay, so we can do like HTTP .dir. We can just pass it in there, and then it can be like what is it? It's my mouse got. If anyone's curious, my like screen is here, and my like laptop screen where like I have OBS running is here, and my mouse was below, and it just got stuck. Cool. So we just take this, right? We pass it static. And then I can fix the problems when they come. So we have this. This is fine. And then it's saying there's an error, right? Where we're not actually using our file like system handle thing, right? And the way we fix that is we give it a pattern, and then we give it an HTTP handler, which is FS. And that's it. So now what we want to do is we actually want to run the server. Pretty easy again. http://listen and serve, and we can give it the address, which is our port, and then we can just pass a nil, because that's what we're doing. Now we have to handle the actual like air server, right? Because we always have to handle those. Does not equal nil. Log fatal, air server. So now if we go there, we're running, and what was our port? 8080. So theoretically, oh yeah, we don't need this anymore. So close that. We want to be here, localhost 8080. Hello world, which is our little thing here. Just to show that it'll change, we'll put in this, and now we have ASDF. So we're serving our little static page, In my case, when I was running it, I was serving a video game, so it was serving like an index.html page plus like some bundled up JavaScript that was compiled. Or compiled just sounds like the wrong word for me when you take TypeScript and you turn it into JavaScript. It feels more like a transpile or something like that, but whatever. So this is working, which means we can now get to the actual functionality of handling logging and handling conditions. The namesake is of this video is to do get condition. So we're going to start with the other one, which is logging. So how do we actually do it? For this to work, the reason why we were getting an error, I believe, is we weren't actually handling it with the correct arguments. So it needed a response writer and it needed a request. So now if we do this, right, you can see we're not getting errors anymore. So that's cool. And now what we can do is we can do our data logger function. So we want to make sure we have the right method, right? In this case, I'm expecting a post because the user's basically asking to post their logs. So http.method post, and then http.error. I always got to do error like that. W method not allowed, http.status method not allowed. Cool. And then we actually just want to return because we're done in that case. Otherwise, we want to read what is in the body. ioutil.read all, right? And we're going to get the body of the message from the user, which should be their log file. Now we need to handle our error first, always in Go, right? And then we can do like http.error again, in this case. Did I mess up or something? I don't think I did. W error reading request body, and then it can be http.status bad request. And then what is going on? It's deprecated, yeah, sure, but it's just convenient. Oh, this. There we go. Okay, otherwise, what we want to do is we want to do our body.close because we need to close the body, but I want to be able to just be a little bit more convenient. So now what we need to do is we have this, we're going to make assumptions. One, that the log is in the file of JSON, like the actual format is in JSON. And then what we're going to do is we're going to write it into a log directory right here, which you'll notice is being made. Where is it? If it doesn't exist, we're making it right here. So we're guaranteeing that it exists. So now what we're going to do is we're going to actually, yeah, okay, sorry. So I'm kind of curious, could I just do anyways. Okay, so what we're going to do is we're going to make a log file and we're going to do a for loop. The reason why we're doing a for loop is basically we want to make sure that whatever file we make has a unique name. So let's make a unique name, and we're going to make it uuid.new. Now, where does uuid come from, right? It's going to be from this right here, this Google right there. And we actually need to install it, I believe, because the way this one I really just am not a huge fan of, to be totally frank, where you import from a GitHub, and if the GitHub is messed up or changed, I guess it's always a problem. It just feels more obvious here, where when you're importing and when you're using a package manager instead of just taking the code, you're always going to run into the potential of just downloading code that is not secure, code that is malicious or whatever. So let's remember how to go install package. So go get. Is it this? Oh, and then I missed out on this part. Nope, come on. To add it, go get. Oh, it's go get. And it probably said that right before and I just didn't see it because I just wanted to do it. Okay, cool. So now we got this and we're good to go. And now we have an error where it's like we're not actually using it. So let's use it. So the path is going to be equal to file path dot join as per usual. We're using our log dir, which again comes from right there. And then what we're going to do is we're going to pass it the log ID dot string plus, and we're going to give it an extension. So we're using a UUID to create the file name, and you'll notice we're wrapped in the for loop. And basically, we could be like really safe and secure and assuming that we're never going to get a duplicate. But on the off chance that we do, because there is an off chance, part of like this whole video is basically saying that even though random is very reliable, it is not always reliable because it is random. So what we want to do, error does not equal os.stat path. We're not going to use that. So if os.isNotExist, so if the file does not exist, then we're going to write to the file, right? So file create file error equals os.create path. Works for me. And then if create file error does not equal nil, it's just a lot of like this kind of pattern, which isn't necessarily a bad thing, it's just a thing. Error w could not create a file to log to, and then I think we're going to do like an HTTP status internal, yeah. That works for me. Okay, so let's go back here, and then we are going to return. Okay. I'm a little confused by what's going on here. All right, we're just going to keep going for a little bit. Otherwise, defer file.close, so that's fine. File.write, we're going to write the body of the user's log, and then we're going to do like a log. Is there like a good log function for like there's default, fatal is equivalent. It's like we really just want to like printf, I guess. Data, oh. So we're just going to say this is where it went, delete this, and path. And we'll do this. Do that. That looks good to me. And then w.write header http.status created, and then we'll break. So what you see here, this is the basic structure of it. If this exists, does not exist, then we can create the file, and then we keep going. We break out of the for loop right there. Otherwise, we just go back to the top and we start till we create a UUID that is not in existence in our logs directory. Okay, so file create error. Let's see what the actual problem is. Create file error. Let's just go run src. Undefined file, undefined file. So that's what's a little weird here. Oh, oops. Got it. There it is. Defer file.close is going to be wrong because it's not capitalized. And now if we run, go run src go, then we're running. I don't like let's do like a log printf listening on port, and then we can pass it in %s right? And then we can do like, is it just port? Yeah. So now we're listening on port. If I put it below here, I don't think it's actually going to show up. So we have this like hopeful. Ooh. My mic just fell. Sorry about that. Hopefully that wasn't. I'll edit that if it's too loud. The about time 30. Okay. So listening on port. So it's like a hopeful thing. Otherwise, it's just going to log fatal. And there we go. So listening on port 8080. And that's all good. So let's adjust that just a little bit. Take a sip of coffee. And yeah, we can go to the next one. Generally, if this was like a video where I was making something from scratch, like I was doing with Sokoban, this is where we would start implementing tests. But I've already implemented this and I know it works. So you're welcome to test on your own. There will be a link to like the actual GitHub right below. But for now, we're just going to keep trucking along and make the server. We'll check actually the conditions are working, which we're about to get to. So let's go to conditions. And so we have these conditions right here, right? These are our conditions. And now we're going to have this function right here. I see this and I already see like this should really be block new like this, I assume. That feels like the way they like to do it. So what we're going to do is we're going to go into block.go. This is going to be, again, part of package main. Simple enough, right? And then we're going to do a type block, which is going to be for block randomization, if you recall. And basically, the way block randomization is going to work is instead of doing it randomly, what we're going to do is we're going to have a block of conditions. So in this case, right, we have it right here. This is our block of conditions, A and B. And so what we're going to do in block randomization is we're going to go from this one to this one, 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 right? So if you do it like that, the first user will get condition A, the second user will get condition B, A, B, right? And you're just going to get this like this. Now, when you're running actual user studies, this is a quote-unquote no-no, right? Because you're guaranteeing that every odd participant is going to get condition A, and every even condition is going to get is going to get condition B, which is not what you want. You want to try to get it random. So you may have participant 1 get condition A, or they may get condition B. So what you really want to do is you want to shuffle this. Now, alternatively, there's something that I believe is called K-block. K-block randomization, right? And that's basically where you have, instead of a multiple of 1, K could be 2, and then you'd have 2 instances of A and B. If you did K equals 3, you would have 3 instances. If you did K equals 4, you would have 4 instances. The one thing you want to be careful about, right, is say I have 50 participants. I don't want to necessarily make K to be too large. I want to make sure that K is divisible by this number. So 4, 48. 4 is not divisible by 50. So that's something you wouldn't want to do, because then you're not guaranteeing an equal number of participants across each. Where if, for example, I just kept it at 1, where it was like this, then I'm guaranteeing that 2, 25, it's going to work. So 2 takes me to 4, which doesn't work. 3 takes me to 6, which doesn't work. 4 takes me to 8, which also doesn't work. And you can see how the math goes. You just want to make sure that things are divisible. So the way we do this is we keep an index into this array. When the index gets too large, then we can reshuffle the array and then start selecting from it again. So this is our int, right? This is our index into the array. We're going to have some kind of random thing. And basically what this random is going to do is it's going to allow us to shuffle. Now, because we're in a server context, right, we actually need to worry about the fact that things may not, like if 2 users request a condition at the same time, we want to make sure that they don't get the same index, and then we get like a double plus and things get messed up. So we want to have some kind of mutex to guarantee that we're going to have thread safe behavior. We're going to have our list of conditions, And then we're going to have our block, which is our strings. Now, because this is like super gross to look at, we're going to do it like this, where we're just going to do some formatting. So everything is a little bit easier on the eyes. So that looks a lot better. And then we're going to make a function, block new. So we could name this k int conditions string, and then we'll return a block. Now, oh yeah, this is Python-y, so it's like this, cool. Now, I'm not going to use k here, because even though I think it's perfectly fine and understandable, it's pretty, like, if you don't know what k-block randomization is, you'll have no way to guess it. It's kind of like the same thing, this should be there. It's kind of the same thing when if you've like using A star before, like there's a common notation where you have like G and H for like, this is path cost, this is the heuristic cost. But if you don't know it, it just makes zero sense to you. So I want to kind of try and make the code a little bit more friendly, even if no one besides me is going to use it, because at some point I may come back to it. I may forget what k-block randomization even is. Okay, so we're going to make a new rand. And basically we're going to seed it, right, with just the time, because that's fine. Unix nano, that's fine. And there we go. So we've seeded our random function right there. Then we're going to do block, make string. So we're making a string, right? An array of strings, sorry. The length of the conditions. And then we're going to times it by the size multiple. So this is our k, which is the size of the block. Index is going to be equal to 0, right? For blank c in range conditions. So we're looping through the conditions. Then we're going to do a for the size multiple. So this is our k. Block index equals c. And then we're going to use that index to do like a index plus plus. So now what we're doing is we're actually creating this whole like array of conditions. So if we just have like size multiple is equal to 1, then we just get a, b. If we have size multiple equal to 2, we get a, b, a, b, b. Now there's a potential bug here where what if size multiple equals -1? Because we're using an int here, right? So what I want to do is I actually want to do an assert to do some kind of check. It is commonly used for Go. I want to do, actually, if I can't do, is this the closest we get to it? Okay. So what we can do is we can say if, because I'm just going to make it fatal. I don't want to do like this whole like error thing because it doesn't really matter for me. So I want to do if size multiple is less than or equal to 0. I'm just going to break because I don't want this thing running at all, to be totally frank. And it's got to be size multiple, and we'll put in like a %s. I don't know if that's the correct formation, but we can come back to that. Yeah, must be greater than 0. And then we'll give it size multiple, and I'm gonna guess it will like go run src go. Oh, it's giving me that right now. Go print int. What is it gonna be like %i or something? Format string. Or is it d? %d. Sure. All right, cool. So now we're doing that. So now what we want to do in our block is we want to shuffle it. Go comes with something for us, so we're going to give it the length of the block. And then we actually need to implement our little function. Func I, j, int. So these are both integers, right? Do that. And then we do block I, block j. So this is actually really convenient. Block j, block I. And that's it. Now what we want to do is we actually want to make our block, right? So B block, right? Now we're doing like this. Index 0 like this. Rand R mu. We can make the mutex right now. Conditions, block, block. For some reason, all these like constructors, I really feel like you should do it like this, where you like just make it easier on the eyes. I don't know why this is easier on the eyes. Maybe it's actually not, but I feel like it is. Okay, failed. Oh, because I named this block. Got it, got it. Okay, so we're creating our block, and that's okay. We have our block, but are we actually using it? And the answer is no. So let's start using it just a little bit, and then we're going to run into some errors, and then we'll go back into this block function, and then we'll come back here. So first thing, we want to make sure the method is correct, right? Method post, and then we can do something like print ln find http.error. Cool, and then we'll do like w, we'll do method not allowed, and then we'll do http.status method not allowed. So that's fine. Then we return because we're done if that occurs. We're going to add a log just so print ln, right? And it's going to be like received condition request, right? w.write, not w.write header. I don't like this W and R thing, by the way. If anyone's curious, that is okay. So fmt.print, just print, and we're gonna do fprint. So we're gonna say we're writing to W, block get condition. So you can see we have this thing that we need to do. Get condition block. So what is get condition? Let's start implementing it. This is get condition, and you can see that's going to do that. So once we actually have this, we're going to be fine. So the first thing to do is we receive this block. So we want to do block.mu.lock, right? And then we can use defer. Love defer, to be totally frank. I think it's incredible. I don't know why more languages don't have it, whatever. So we basically lock our mutex and then we unlock it when we get to the end of the scope. But until we get to the end of the scope, we're basically saying no one else is able to access or use this block. They're able to wait, but they cannot use it. So then we do block.index. If it's greater than block.block, right? So the length of the block. Then what we do is we say block.index is equal to 0, right? And then we just need to reshuffle our block. And block, and we just have this kind of like unfortunate little notation right here where we just got to do a bunch of blocks. I have a feeling if there's, well, I know for a fact there's a way to, instead of having to do it like this, you could attach it into the actual struct and then it would be fine, but we've kind of already gone all in on this like procedural-ish style. So we're just going to keep going on that. So what we did was if the block.index is greater than or equal to the length of the block, that means we've gotten too large. We reset the index and then we shuffle it. So if, for example, we had like A, B, now it may become the two options. It may become A, B again, or it may become BA. If it's larger, then there's more variation. So it's just combinatoric, sorry. So now we get the condition, block.block.index, right? Then we do block.index plus plus, and then we can return the condition. And so I hope when you see all this, what you realize is block randomization is a complex sounding name for something that is outrageously simple. Okay, so now if we do go run src go, everything is working in theory, but we haven't actually tested our block randomization. And I do actually want to test it a little bit. So what I'm gonna do, clear screen ls, so screen s go, screen s server, so control AD, screen ls, you can see there's one server, and then we can do screen r, just server, I think it is, yep, go run src star.go, so now this is running, and if we go back to here, you can see it's running. If I make a change back to like, I didn't save it, of course I didn't, sorry. There we go, everything is working. Okay, so let's make a quick little test function, or not test function, but just a test file. So this is closer to like an integration test, I guess. Oh, oops. So let's get out of there. Let's do touch test.go, right? Test.go, and I'm just gonna copy and paste in my old tests, and we have this, right? And in this one, I'm doing, I actually want to change this to be like ABC. Yeah, ABC. So I'm gonna reattach real quick, restart the server, go run. If I do go run test.go, it's not going to work yet because we're not testing for the right thing, but let's actually look at the test thing I wrote beforehand so we can see it. So I want the counts, and I want to get rid of, I just want to get rid of this one. This will be C, this will be B, this will be A. Let's double check so I'm not terrible. There we go. That looks good to me. Okay, so we do this. So basically what we're doing is we're starting here and we have this map of counts, right? So it's a string to this with A, B, and C, and we also have an error thing. We're gonna do it in range of, there's 3, so let's do like, let's actually start really tiny. Let's start with like 30. So WG add 1. What is WG? It's a weight group, right? And so basically this weight group is attached to this. So we're saying add one thing to wait for. We're using go func. This is starting a go thread, which is going to be like basically just like a lightweight version of a thread. And then what we do is we do defer WG done. So once this go func is done, it's going to decrement this weight group. Time.sleep, we're just making it random, so every condition request isn't just like this, right? It takes a second before it goes. Then we're going to call get condition. We'll come back to that in just a second. So after we've made all of our go funcs, we were going to wait for this wait group to actually finish, and then we're just going to print everything out. So we don't need this. We do need to get rid of these, right? A, B, C. We can get rid of this. And we'll come back to this error thing in just a second too. Okay, so now we can actually go into what we didn't describe, which was get condition. And because, yeah, so because for whatever reason, this seems to be the go way, we'll make it to a capital get condition. So we have our mutex again. Do we actually use M? Oh, we totally do, nice. So we have this mutex, and basically what we use it for is to basically lock and unlock. We could totally just do like m.lock defer m.unlock, but for one line it feels like a bit much. Anywho, what we're doing is we're doing our localhost connection to port 8080 to our condition request, text plain, nil for the IO reader, I guess, because we actually have no body to send to the reader. We just have no body to send to the reader, or to the reader, which in this case is our server. We check for an error. If the error is nothing, right, or does not equal nil, then we actually increment our error, which we already talked about. Otherwise, we go into deferring to close our body, which we'll close right over here. And then we read in the body, so this is where we're getting the response. If there was an error, again, we do counts plus plus with a thing right here, and we also just print it out just to see what's going on. Otherwise, we lock, unlock, and then we print out the body just so we can see it. I don't really want that, I don't think, for this test. And then we can do count string body plus plus. So if we run it, we can see what we got. And you can see we got this like perfect little thing, 10, 10, 10. So it's working. If we made it like 33, right? I'm sure you can guess we're gonna hopefully be getting 11, 11, 11. But as I was saying before, with that whole being divisible by thing, if we aren't divisible by, we're not guaranteeing the correct count. So even if we do 3, right, we're guaranteeing that we're going to have, did I do like a, that's interesting. If I do 6, everything is totally fine. Everything is not totally fine. Okay, so let's see in the server.go, block new, we go into here. Fatal call as possible. That's okay, I don't really care. Okay. So we do our defer block index. Oh, I'm silly. So the reason why this was happening is, well, if I go back into here, let's make this 3, because you could see we would have occasional errors where this would happen, right? Screen R, do this, do this, do this, and then we do it, and everything's totally fine. The reason why this was an error, right, is that the index was getting messed up from the previous calls because it was assuming, the server was assuming, that is just a total like correct, it's assuming that the blocks aren't like different between different function calls, right? Whereas each test right here was assuming that the server started new, which it didn't. So now that we actually have this working, you can see how block randomization works out. It is, I think, a pretty cool little technique to guarantee that you get a very good distribution across your participants in terms of the conditions that they're assigned. It's not very hard to implement. If you just want to use this server for yourself, you can just go on GitHub and yank it. I believe it's under the MIT license, and if it isn't, it will be by the time you're seeing this video. And yeah, I'll just show you real quick so you can find it yourself. github.com. Apparently I was looking for, oh, that's interesting. I am not signed on to GitHub in on Chrome. Why was this up? This is like a very old project. I'm surprised this shows up at all. Okay, anyways, go log study server. Yeah, it is under the MIT license. It's right here. So if you want to use it, you're more than welcome to use it yourself. You can serve users web pages, then they can send you back logs, and you can also assign them conditions by basically calling get condition, and then your web page can change its behavior based on the condition. You could also use it for not a web page based study where like you run an app or something through like Unity, I know is a common one. But yeah, this is block randomization in Go. Hopefully this was a fun, interesting video, and I hope you enjoyed it. And yeah, I'll see you guys in the next one. Bye.